Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank ExcelR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about ExcelR and I enroll in ExcelR course. It was really good experience. Our course has been taken by Mayur sir.
Good evening, all. I hope you all doing well. Okay, we'll start the session. Adil sir, good evening. Sir, is I'm audible?
Hello, good evening, ma'am. Yeah, you are.
Yeah, good evening, sir. You can take over the class, sir.
Okay, good evening.
Thank you.
Hi, good evening, everyone. Okay, may I know where we left yesterday, day before yesterday? Yes, may I know? Okay, I guess we discussed the design strategies in the last session, in the last part of the session. Right, we were discussing some strategies. Let me share the screen. Okay, is it visible? Yes. Okay, I guess my screen is visible to you. So these are some of the strategies that we discussed on that very day, right? We have got divide and conquer, we have got greedy method, dynamic programming, backtracking, branch and bound. So I hope we discussed them not in full detail, but briefly I have given you the idea about what all these strategies are. Okay, let us move a bit forward and we'll see. Yes, today actually we are going to discuss binary search. Now I guess I have given a brief idea about binary search. Today we'll discuss it in detail. How actually it is searching an element, right? See, it is, I guess we discussed about linear search as well in the last session. Then we discussed about these design strategies. And the most important design strategy, it was divide and conquer, right? And with the help of that design strategy, we will be explaining the binary search. So I hope that divide and conquer is clear to you. If you have any questions regarding that, please do let me know. Only then we'll go forward. Yes. If you have got any questions in divide and conquer strategy, do let me know. Then we'll be explaining this binary search. And we have also discussed the recurrence relation for that divide and conquer. ATN by B plus F of N. And we also know how to solve those recurrence relations. We have discussed that in, I guess, on Thursday or Wednesday. Okay, so we'll be starting this binary search. Binary search is simply a search algorithm, right? It is a search algorithm in which what we are doing, we are searching an element. But unlike binary search, unlike linear search that we discussed in the previous session, we were searching an element in a linear manner, in a sequential fashion, right? In linear search, what we were doing, we were searching in linear manner, or I can say linearly, right? So at that time we also discussed it. We can have a successful search or an unsuccessful search. And for a search to be successful, there should be an element which we are going to search, and that should be present in the list. That is a successful search. But when the search is unsuccessful, it means that the element which we are going to search is not present in the list. So based on that, we have got two search, successful search and unsuccessful search, right? And accordingly, we can have complexities. We call them as worst case complexity and best case complexity. And in the best case, we did that with the help of an example when the element is at the very first location. So at that time, the complexity is order of 1. And for successful search and unsuccessful search, in the worst case, it is of the order of n, means whatever would be the size of that array. So this is what we did in the previous session regarding the linear search. Now in binary search, it is again, we have to search an algorithm. But in linear search, the complexity is order of n. This binary search actually came and it is making use of this divide and conquer strategy. And it is having very much less complexity as compared to the linear search. So that we are going to check and that we are going to explain with the help of an example. So as I already discussed, binary search simply a searching algorithm. But how it is searching? Yes, it is making use of what? Divide and conquer strategy, or divide and conquer paradigm. Okay, now what is divide and conquer? That we also discussed in this part of the session or previously. So here if we see, we have got an array. Let us take an example. With the help of an example, we'll see. Let me take an array in which I have, and there is a condition for a binary search. May I know what is that condition? Yes. Quickly answer in the chat box. There is a precondition for conducting a binary search. Answer in the chat box. Array is divided into two parts. That's fine. But there is a precondition in order to conduct a binary search. Good. Okay. The condition is that the array has to be sorted. The array has to be sorted. Only then you can conduct a binary search, right? This is the primary condition. So let me take an example. Like suppose I have this. Okay, let me take these elements. And I want to search for an element. You guess, give the element that you want to search among the list using the chat box. Involve yourself. Don't be mute spectators. Pick up the element that you want to search. Okay, great. I will take randomly any element. Good. Let me take this one. 56. See, we'll start explaining the algorithm at the same time. The very first step is start. Initialize left is equal to 0, start index, and array right is equivalent to array length minus 1. Simple. So we'll be starting with the index 0. And what is the last index? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Is it fine? So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it would be 10. So the first index is 0 and the last index is 10. Now what is the very basic step of divide and conquer? Yes. We'll be simply checking whether the array is null or not. If the array is null, then means there is nothing to sort. So for that I have to check if this left is less than or equal to right. It means when 0 is less than or equal to what? 10. Yes, it is. So I will be calculating this. If it is not the case, then it means if like suppose 0 is greater than 10. So what does this mean? Already the array is sorted, or we can say there is nothing to sort. So these things we have to keep in mind. So the very basic condition 0 is less than is 10, it is true. Then I have to do what? I have to calculate the mid. Follow the algorithm. Let me choose a different color. Okay, so I will be calculating the mid. Now what is mid? M, I am supposing it. Mid is equivalent to low plus or left plus right. See here. Can anyone tell me what is this? Why I have taken mid like this? Yes. Tell me. Why I have taken mid is equivalent to left plus right minus left divided by 2. Yes, tell me. Why I have written like this? Yes. Can anyone? Index is n minus 1. Initially left W will be 0. Have anyone among you heard about this? We call that as integer overflow. Do you know integer overflow? Okay, let us discuss integer overflow. Divide the element for make a short list. Actually, there is a concept we call that as an integer overflow. Let me explain in a while. There is a concept we call that as integer overflow. Let me write over here. Integer overflow. See, actually, if we simply write now, low plus high divided by 2, right? So it would be like, I can say this now, there can be overflow condition. Right now, what is this overflow? Integer overflow. And you might be knowing well, for every programming language, each integer has a limit, or I can say there's a size limit for it. For example, if you got 2 bytes, 4 bytes, etc., right? So for that purpose, what we are doing? There might arise an overflow. Means there is a limitation for Java to store up to some limit. For example, there is a limit of, I don't remember, it is something like 2 raised to the power 32 or something like that. So after that, if the number exceeds, it will show overflow. So because of this overflow, the calculations can become incorrect. right? So for that purpose, what we are doing? We are doing it like this way. Like you can have it. It would be like, suppose mid is equivalent to, actually it is low plus high divided by 2. But what I am, how I am writing it? I am writing it left plus low plus high minus low divided by 2. I am writing it like this. M is equivalent to low plus, how? High minus low divided by 2. High minus low divided by 2. So this makes a difference. Now you say how? Because if I write simply low plus high divided by 2, it might overflow because of the size. But what it is doing, it is actually doing a safe calculation. We call that a safe mid calculation. Because of this, low plus high minus low divided by 2. Now you will say, why is it safe? See, actually it guarantees this high minus low is within the lower bounds, right? So this high minus low would be within the lower bounds. For example, I can tell you like this. See, this high minus low can be within lower bounds. I write high minus low. It can be within bounds of the integer, because I already told you, whenever you are adding two integers that are, I can say like on the border, or I can say that are about to increase the size limit. So when I am adding those two integers, what will happen? Simply it will cross the bounds. So we will get the incorrect result. But what I am doing, I am actually, first step is that now I am subtracting that high minus low. So what is the possibility? Possibility that we are going to the safe zone. So after that, if we are adding the low again, then it will not cross the bound. So that's why I am saying that it is safe to do the calculation like this: high plus low, low minus high minus low plus high minus low divided by 2. I say low plus high minus low divided by 2. So this is called as integer overflow. Whenever we are adding two integers and they are crossing the size limit of a particular programming language. Hope it is clear. Yes or no? Is it fine? Yes. Just a confirmation, yes or no? Integer overflow. So that's why I have written the calculation like this. If you are checking, why I am writing like this, left plus right minus left? It is simple, because in programming languages, these integers have a limit that we know. Like suppose 2 bytes, 4 bytes, 8 bytes, 2 power 16, etc., etc. So when we add two integers, they might cross the limit and we can get the incorrect result. So in order to avoid that, what I am doing, I am simply first subtracting those two values. When I am subtracting, then I am dividing them. So it simply reduces them to up. Then again, I am adding some low value to it. So it means it will not cross the bound. So that's why we are saying that in order to avoid this integer overflow, I am doing the calculation like this. Okay, fine. So after that, what we'll be doing? Let me, no, I'm not supposed to clear all the drawings. Okay. Now we are supposed to find this 56. So I have found that it is 0 plus right minus left. It is 10 minus 0 divided by 2. Left plus 5. 0 plus 5 divided by 2. What it would be? Yes. Or simply 0 plus 10 divided by 2. Yes. It would be simply, I guess, 5. Isn't it? Okay. So when it is 5, so mid is 5. 0, 1, 2, 3, 4, 5. See here. This is the mid value. Now what after that? This is the step. if ARR of mid is equivalent to target. What is our target? We have set the target as 56. So what is ARR of mid? It is 16. 16 and 56. If it is equivalent to this, so what do we say? We will say target found, sir, is successful, and we will leave. We will exit the loop. But in this case, our target is 56. So what we'll do? Since this is not equal to this, so it will simply go to the else part of the loop, else part of this condition. So it will simply compare this. It will compare 16 with 56. So if 16 is less than 56, then what I have to do? I have to set different left is as such. I have to set different this mid and different high. So if it is greater than this, 56 is greater than this, then again I have to change the left and mid. So what is the case over here? You tell me in the chat box. Which case we are going with? Yeah. Yes, mid is less than target. So if mid is less than target, then what we have to do? This mid is less than target. So we have to change our low and the mid will automatically change. So the no low will be what? See here, it is simple. Let me change the color of this. Initially, this was low or left, we were saying it. And this was high or we were saying is right. Now what happens? This value target is greater than mid. So I will be going with only this part of the array. Right? So for this, what would be the new low or new left? It would be mid plus 1. What was mid? It was this value. So the no low will be this and high will be this and new mid will be this plus this divided by 2. Right? So what would be the new mid? Tell me. Yeah. What would be the new mid now? It would be the place over here. Now this is new low. This is new mid and this is high as such. So what I will be doing? Now I will be comparing this 56 mid value, the new mid value with the 56 itself. It is the target value, right? So I will check whether this mid is equivalent to target. Is it equal to target? Yes. So it is equal to target. I will say that what? I will say element found. So the search is successful. And in how many steps I did it? How many steps I did it? Can anyone? Simply only 2 steps. I did this in only 2 steps. Right? See, if I will draw, let me draw a graph for this process. Okay, see here. This was the array. I divided it into 2, right? First array got neglected, cancelled because this 56 is greater than mid. Now I have only the second part. And the second part of the array contains what? Simple. It is 21, 34, 56, 78 and 76. So again here what I am doing, I am dividing this array again into 2. But while dividing, I found that the element on which I am dividing the array is the element which is the target. So here itself, whenever I am trying to find the mid, it is the target itself. So only 2 steps I am doing it. So what is the complexity of this algorithm? Can anyone tell me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it is, what is the complexity of this algorithm? Actually, it is 3 steps, not only 2, because third step we are also comparing. First mid, second mid. So is it big O of 1? No, it is, if I will write order of log n. Now it is order of log, what is the value of n? 11 to the base 2. What is log 11 to the base 2? Can anyone? Log 11 to the base 2. No, it cannot be order of 1. Order of 1 only when it is the first element. This is the mid element in the very first step. If it would have been 21. What is order of log 11 to the base 2? No, it is not 1. Order of log 11 to the base 2. I have shown you in the previous session how to calculate these logs. It is simply 2 को क्या power जाएगा? What will go to the power of 2 such that it will become 11? Yes, what would go to the power of 2 that it will become 11? It would be 3 point something, isn't it? So yes, 3. So in these steps I am going to find this algorithm. I am going to find this 56. So in 3 steps only I am finding 56 in this array. And if I will be using linear search, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I will be finding it in 9 steps when I will be using linear search. But in case of binary search, I am finding this 56 only in 3 steps. So whenever the value of n is more, or whenever the number of elements in the array are more, we can say that it simply reduces the complexity to logarithmic. Hope it is clear. Yes or no? So this is how is actually binary search working. This is the cracks and in detail working of binary search. If you have any questions, you can ask. Then we'll be doing it as programming part, both iterative as well as recursive. So I will show there. Yeah. Do any questions? Ask in 10-15 seconds. Then we'll go to the programming part. Okay. Questions, yes or no? You must ask questions as well. Otherwise, I will think you are not listening. Okay, fine. So let us do the programming part. Let me clear the drawings. Let us share this sheet now. Okay. Is it visible? Online compiler I am using. You can use any online compiler just to save time. Is it visible? Okay, fine. So let me write the program. First, we will be explaining this program. It is same as I have used the algorithm. There is no difference in it. See here, you can check. Nothing difficult in this program. Let us do it line by line if you are finding any kind of a difficulty. See here, simply I am just checking whether the array length is fine or it is 0. It is empty. So I have to check for that. I am simply checking ARR dot length. If it is 0, I will simply return -1. So it means I don't have any array, so there is nothing to search, right? Then, like in the algorithm, what I am doing, I am simply setting the parameters low and high, or I can say left and right. So here I am simply setting left is equal to 0, that we discussed in the algorithm, and simply right is equal to whatever is the length of the array -1. Like in the previous step, we did it n -1. Fine, it is also simple. Nothing difficult till here. Then we will be using while loop. So keep it in mind. Always remember it. Whenever you are using loops, so it means that you are using the iterative binary search. Right? Keep it in mind. Always remember it. Whenever using what? You are using loops. Whether while loop or for loop, whatever loop you are using. So it simply means that you are using, what are you using then? So it means you are using iterative binary search, means you are iteratively trying to find an element in the binary, in this array. So here, what are we doing? We are actually iteratively finding the element. So it is iterative binary search. So here also, what I am doing, I am implementing the integer workflow. Again, always remember it, integer workflow. These questions are asked. See, and these are the questions that make the difference in the interview. You will be asked binary search, how it is working, how to find the element, what if element is at last, what if element is at mid, what if element is at first, how to prevent the integer overflow. So these are the questions, these are the terms that make the difference actually in the interview. Because everyone, almost 80-70% students will be knowing binary search, complexity, by remembering the things, etc., etc. But these are the points that actually make the difference in the interview. Iterative is simply when we are step by step trying to find the element. See here, it is simply trying to find the element while going from left to right, from first, second, third, fourth, and so on. So it is iterative. Iteratively, we are doing it step by step. Right? For that, we are just checking the integer overflow that we discussed. Right? So integer overflow, how we are checking that integer overflow? It is simply left plus right minus left divided by 2. As I already told you, it somehow makes the calculation safe, because most of the time, not most of the time, sometimes I can say, these calculations can lead to overflow. So in order to prevent that, we are doing the calculation like, and being a programmer, we should be able to do this. Right? Simple then, that we did. If your mid, ARR of mid, it is equivalent to target. Target means the element which you are going to found, that we discussed in the previous example. So if it is the case, very first step, order of one, element found, and that's it. If it is not the case, then we have to perform the comparison. And for what comparison, for this comparison, what we are actually doing? We are actually simply comparing our target with the mid that we have calculated. So here we are actually doing what? We are calculating this ARR of mid with the target. If it is less, traverse the left part. If it is an array, if it is less, traverse the left part. If it is more, traverse the, if it is greater than, traverse this. If it is less than, traverse this part. Right? So based on this mid, that we did in the previous case as well. Okay, then see here, it is simple. else return 1. We can simply say if the element is not there, we have to traverse, right? Whole array, and we will be done with that. Then it is recursive binary search. So that was simply what? That was simply iterative binary search. Now we have recursive binary search. Recursive binary search means we'll be making use of function calls, right? Recursion will be using, or I can say function calls. For that, I will be using this binary search recursive function. And in this, I have to pass some argument. The very first argument is the array. Second thing is the target, the element which we are going to found. Third is the low, or I can say left. And the finally, we have to set right. Right. So these are the 4 parameters that we are giving to this binary search recursive call, recursive function. So here it is the base case. Base case is what? If left is less than right, simple, then return. If left is greater than right, then return -1. Means the array is not there. There is nothing to search. Or else we have to find the mid. Mid is simply left plus right divided by 2, or if you want to prevent the integer overflow, it would be left plus right minus left divided by 2. Fine. Then you have to compare your mid with the target. If mid is equal to target, return mid. Else, if mid is less than target, set the new what? Set the new mid and set the new right. So it would be target would be as such, array would be as such, and new mid would be mid plus 1, because it is now in the right left part only. So we have to set this new mid. It would be simply mid plus 1 would be now low high, and this left will remain as such, and this new mid would be this plus this divided by 2. Right. Similarly, if it is the right part of this array that we did in the previous example, you have no low, it would be mid plus 1, it is mid, and it is high. High would be same, or right would be same. So with this, we are actually doing it recursively without making making use of while loop that we did in the previous case. So this is how we do it recursively. Simple. And if you remember, this was the case that we did previously in the previous example, because the element was found in the rightmost array, in the right part of the sub array. Then we are giving this array to it. Let us check. This is the array, and we are trying to find 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can anyone tell me what is the complexity of finding 23 over here? In number, I just want it. Just type the complexity of finding 23 in this example. Complexity, order of what? Or simply number. In how many steps? In how many steps you are finding this 23? Order of log 9. So I just want number. I don't want this. It is log 9. If there are how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be 10 elements. So it would be order of, yes, order of log 10 base 2. What is that? Again, it would be 3 point something. Right. So in three steps, you would be able to calculate this. Here, find this 23. Yeah. What is the best case in this example? Tell me the best case. Tell me the best case. What is the best case in this example? Which element will be found very first? Order, yeah, the order is best case always it is order of 1, but which element would be that is searched for the present element. So what is that present element? Very first element. It would be mid would be low plus high divided by 2. Okay, it is 23 or 16. Yes, is it 23 or 16? You have to check it. Is it 23 or 16? Yeah, do tell me. So it is 16 or 23. Do you know what anything about seal value and floor value? Anyone among you? What are seal values and floor values? Yes. Seal value or floor value? Yes, here, see, actually, what why I am touching these cases now, I just want you to know these things. Otherwise, you can know these things from internet here and there. But the main thing is here, I just want to clear you. Right? So actually, in binary search, we are going with the floor value. So what is the floor value over here? Yes. So what is the floor value? Yes, see here. Whenever you are computing this mid in binary search, we are going with the floor value. For example, let me explain it. If you have, in this case, I guess it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. It was 9 divided by 2. So the value is 4.5. Right? But we are in dilemma whether we will take 16 or whether we will take 25, 23. So always remember it, we are taking the floor value. Now, what is floor value? Actually, we have seal and we have floor. Seal is simply ceiling fan. Ceiling fan means that is above us. So ceiling means above value. In this case, it would be, if it is 4.5, then the value would be equivalent to 5 if seal. Right? When it is again 4.5 and it is equivalent to 4, but when floor value. So always remember floor means is floor tile, that is under of heat. So it would be, that is why we are saying it is a lower value. So for 4.5, we'll be going with 4 if it is floor value. For 4.5, we'll be going with 5 if it is seal value. And always remember it, in case of binary search, we are going with floor value. Actually, there is a representation of this now while we are writing the algorithm. For seal, it is like this. Let me choose a different color. For floor, it is like this. If it is seal, it is this. For floor, it is like this. So this is the actual algorithmic representation of this. So if I will go with the floor value of 4.5, it would be simply what? It would be 5. Similarly, if I will go with the floor value, it would be 4 only. For seal, it is 5 and 4. So what if, what is the case now in this example? What is the mid value? Yes, what is the mid value now in this case? So obviously it would be 16. So the very basic, or I can say the very best case of this algorithm, of this example, is whenever we have to find the element 16, and it would be at the very, we'll find it at the very first step. So the complexity of this case would be order of 1. Fine. So this is this, and you might be knowing it well, why this logarithmic is coming. Logarithm is because at every step the complexity of the problem reduces to half. Because at each step what we are doing, we are dividing our problem into 2. In the further step, we are again dividing it into 2. Means at every step the problem size gets reduced to half. At in the very first step, for example, if we have got 1000 elements, so in the very first step we are dividing it into 500. So 500 already discarded, no need to traverse them, no need to search among them. And in the next step, 225, 225. So in the next step again, one more half discarded. Similarly, in third step again half, and so on. So if we'll be reaching from top to bottom, the steps would be log n. If you have read something about trees, so if you check the level of this tree again, what is the height, I can say, or level, sometimes we call that. The height of the tree is what? It is again log n. If you have got n nodes and a binary tree you have got, so what is the height of that binary tree, maximum height? So you can say log n, right? Again, in the worst case, if you have the problem of binary search, in the worst case, it means when the element is either first or either last. So in the worst case, you have to search all the elements. So the number of levels, or I can say the number of, or I can say the depth of the tree, it would be of the order of log n. So that's why always remember, whenever it is the case that if every step you are dividing your list by half, so remember that that kind of division is logarithmic division, right? So that is the logarithmic division, means that every step you are dividing it half, and it means in the worst case scenario we will be having the log n steps. So this is actually what we can say the complexity of this binary search algorithm. Okay, hope it is clear. If you have any questions, you can ask me. See, then we'll run this program. It is simple. I've already checked it. Yeah, element found at index 5, 0, 1, 2, 3, 4, 5. And what was the element? Element was 23. So it is index 5. 1, 2, 3, 4, 5, 6. Yes, it is index 5. So this is how do we perform binary search. Yeah, is it fine? Both iterative as well as binary? Just a thumbs up if it is fine. Then we'll go to another concept. We call them as sorting techniques. In index 5, we found 23 elements. Yeah, the index of 23 is 5. You can check. 0, 1, 2, 3, 4, 5. You can check the index of 23. It is 5. It is only showing the index. It is not number of steps. Because it is a search technique, so here we have to check whether the element is there or not. Okay. Any other questions? This is an important topic. And one more thing about it. If you remember, what is the recurrence relation for binary search? That we discussed already. What is the recurrence for binary search? Someone please write in the chat box. Yeah. May I know the recurrence for this? Good. Actually, it is not off and it is off. Can you check what is this actually? Yes. Recurrence for binary search. Yeah, I am waiting for your answers. As I have discussed it previously, that is why. Only few people are giving the responses. Tn by 2 log n is not there. Tn by 2 plus 1, it is fine. Tn by 2 plus f of n, it is also fine. Tn by 2 plus order of 1, it is not the case. Okay. It is simple. Let me write it. T of n by 2 plus, I can write like 1. Can anyone solve it? How do we solve it? A equal to B, and tell me which case we are actually following of master thumb. F of n equivalent to 1. So n raised for log a to the base b. What is that? N power log of 1 base 2. It is equivalent to, please answer. What is it equivalent to? Log 1 to the base 2 equivalent to what will go to the what will we power 1 so that it will become? Yes. 2 को क्या पावर जाएगा, that it will become 1. It is n raised power 0, that is equivalent to 1, and f of n is also equivalent to 1. When both the functions are equal, so we will say it is simply multiply by log n. So it would be order of log n. Is it fine? Is it so? Yes, we can take 23 as mid value. One doubt. How you can take 23 as mid value? Just tell me. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9. Or I can say 10 divided by 2. It is 5. Not 5. It is 9. 9 divided by 2. So when we say 9 divided by 2, it is simply what? 4.5. And the 4.5, which value of 4.5? Always remember, I told you, we discussed it is floor value, not the seal value. So it would be simply equivalent to 4. So that is why the mid value for this is 16, not 23. Clear? Just confirm. Okay, great. Fine, fine. Okay, so with this, binary search is completed. If you have any doubts, or I guess there is nothing left in binary search now. You will get any question if you will get, whether in gate, whether in competitive exam, whether in your like interview exams. I guess everything is clear in binary search. Almost everything. Still, if you have a question, you can ask. Any questions? I will wait for 20 seconds for your questions, then we'll go for a 10-minute break. Yes. So it means binary search is faster than linear search. There is no doubt in it. In linear search, you have got what? You have got order of n complexity, but here you have logarithmic complexity. So that's obviously very much faster. Binary, this linear search is suitable for smaller lists that we discussed previously in the previous class as well. Right? Any more questions? Good to see your questions. Anything you want to ask? Okay, then we'll go for a 10-minute break. We'll be back at 20:15. We will be back at 20:15. Till then, bye. Have a break. Thank you. Okay, welcome back. Yes. Okay, I guess screen is visible to you now, right? Is it visible? Just a confirmation. Am I audible?
Yeah, you're audible, sir.
Okay, fine. See, this we discussed, right? Clear termination, divergence. In iterative mode, it is like na. See, no one asked this question. What is the difference between this iterative mode and recursive mode? Apart from this, na, using for loop and using recursive calls. So this is the difference. In iterative mode, the algorithm is space efficient, more space efficient, because you don't have to. I can say, like, if you remember yesterday also, when we discussed about dynamic programming, that was not space efficient because of that memorization kind of a thing. So here also, whenever we are using using recursive calls, so it is like less space efficient as compared to iterative, because in iterative you don't have to perform any kind of these recursive calls. It is simply making use of loop, so it is of the order of one space. Remember it. And whenever you are making recursive calls, so it becomes a it no longer remains space efficient as compared to this iterative mode. Fine. Okay. Explicit check before MPT array that we are going to do three-way comparison, equal, less than, greater than cases that we are checking, that we discussed. And this is the time complexity analysis. See, order of one when the element is middle element, that we discussed with the use cases as well as with examples. Then you have got average case when it is log in, and worst case is also log in, right? So this way we completed binary search. Now we'll be doing sorting techniques. Now, what are sorting techniques? Do you know what is sorting? Yes. What is sorting? Sorting is simply arranging the elements, or we can say sorting the elements, right? For example, yeah, arranging in ascending or descending order. Great. So simply whenever you have got a list, and in that list the elements are not in any order, they are like in haphazard random manner. So if you have to sort those elements either in ascending order or in descending order, so for that purpose we are using what? We are using sorting techniques. And the very basic sorting technique, I can say it is bubble sort. Right now, what is bubble sort? Can anyone tell me? See, the only purpose of asking you question is to check whether you are in the class or not. Because virtually you can't find. So the only way I can communicate with you, I can check whether you are in the class or not, is when you are typing your answers, when you are typing something in the chat box, whatever I am asking. Right? Now what is bubble sort? Yes. And why is it called bubble sort? What is bubble sort now? See, we have to, while studying these sorting techniques, the ultimate aim, we should be able to make a difference between these sorting techniques. That should be the main goal. Only then the things will become clear. See, I will start with the bubble sort, right? I'm getting answers, compare the elements. Swapping with the adjacent element because the largest element placed at the corner. Okay, arranging. Yeah, fine, good. So it is simple. We call it as comparison based technique. This bubble sort. Right? It actually starts from the start of the list and it goes through the whole list. And what it is doing, it is actually comparing the adjacent elements. And after comparing, it swaps them if the elements are not in a particular order. Or I can say when the elements are not in ascending or descending order, in which order we are like expecting them to be. Or to be more precise, when the elements are in a wrong order. So it is swapping them. And this swapping process is repeated, or I can say comparing then swapping. It is repeated until the list is sorted. Right? So how does it work? It is simple. See here. We will start from 0 to n minus 1. We will go till the end of the list. Right? Then again we'll be repeating using the second loop from 0 to n minus 1 n minus I minus 1. Means, let us take an example, or let me first tell you the steps. We'll start from the first element and we'll compare it with the next. Right? Then after that, if this current element, let me take the example. For example, I have 5, 3, 8, 4, 2. So this is the list. Right? So initially what we are doing, we'll start from this starting element, this one. And we'll compare it with the next one. We'll compare this 5 with 3. Right? If this current element, if it is greater than this element, we'll swap them. Right? The current element is 3. This is the first element. If this 5 is greater than 3, we will swap. Yes, it is greater than 3. So what we'll be doing? We'll be, see, actually, why it is called as bubble? It actually forms a bubble between these two. Whosoever is bigger among these two, a bubble will be formed while comparing them. So a bubble of 5 is formed. So after that, what will happen? If 5 is greater than 3, we'll swap. We'll simply then write 3, 5, 8, 4, 2. Right? Then again, what we'll be doing? Now we'll be comparing this 5 with 8. Again, we'll check which one is bigger among the two. The bigger one will form a bubble. So here 8 is forming a bubble, so there would be no swapping. So again, it would be, the list will be written as such. Means 3, 5, 8, 4, 2. Then after that, okay, let me write the list again as such. 3, 5, 8, 4, 2. Now these two elements will be compared, this 8 and 4. So again a bubble will be formed. The bubble will be formed on 8 and these will be swapped. So the list would be now, this 8 will go here and 4 will come here. So the new list would be 3, 5, 4, 8 and 2. Then finally what? This 8 and 2 will be compared. So it will become 3, 5, 4, 2 and 8. So with this what happens? Till now, what happens? Can anyone tell me what happens by all these steps? What is the fun of, although the list is not sorted, if we check the list is not sorted, but what happens with this? Yes, anyone? Yes, actually the last element that we have written over here, it is sorted now. Right? Only this thing happens. So in very first pass, we call it as pass one. Actually, almost all sorting techniques, they are sorting the elements in passes. So in pass one, only 8 get sorted. Now in pass two, what we'll do? We'll start with the list, but n minus 1, because in first pass we are comparing this. If it has got 1, 2, 3, 4, 5 elements, we'll be having 4 comparisons, because these two. Similarly, in pass 2, we will be having n minus 2 comparison. If it is n minus 1 comparison in the first pass, in pass 2, we'll be having n minus 2 comparison. Similarly, in the next pass, we'll be having n minus 3 comparisons, and so on. So here, what we'll be doing? We have this list. It is 3, 5, 4, 2, like say. It is already there. Now, again, what we'll be doing? Just a minute, I'm sliding this here. We will be comparing 3 and 5. If 5 is bigger, it will remain there. So then we'll be comparing 5 and 4. If which one is bigger, that will go here. Then we'll be comparing 5 and 2. So which will be bigger? 5 will go to last. So after pass 2, the list would be 3, 4, 2, 5. Right, in pass 2. Similarly, in pass 3, we'll be arranging 3, 4, and 2. So it will become 3, 2, 4. Then it will become finally 2, 3, 4, and 5. So this is the list after how many passes? So how many passes we require over here? How many passes we require? The final list would be 2, 3, 4, 5. Then 8. So this is the final list. So how many passes we require? Can anyone tell me? 4 passes. 1 pass, 2 pass, 5 goes there, and in the very first pass 8 goes there. In the second pass 5 goes there. In the third pass 4 goes there, and finally 3 goes there and 2 remains. Then so n minus 1 passes. Right? See here. Actually, this is the algorithm that it is actually doing. If we see now this algorithm, we'll be starting from 0 to n minus 1. Means we'll be starting from this to n minus 1, whatever would be the index. In case here 0, 1, 2, 3, 4, we'll be starting from 0 to 4 in this case. Then we'll repeat for j is equal to 0 to n minus I minus 1. Means in the inner loop, we'll be starting from 0 to n minus I. If it is the first element, so we'll be starting from 0 to first. Means we'll be comparing these two. Then again, we'll be comparing them. If error of j is j plus 1, then swap them. If this is greater than this, swap. If not, then keep them so. So this way, whole loop will be, it is the pass, for pass is this, and for internally we are running this loop. So this is actually how bubble sort is working. And it is called bubble sort because, why it is called bubble sort? Because it is actually forming a kind of a bubble. Right? Whatever is bigger, bubble arises. And we move that bubble to the extreme right. Getting it? So in the next pass, we again trying to find a bubble. Bubble means the highest in that array. We try to move that to the right. So in this way, in each pass, we are moving the biggest, highest element to the right. So in this way, we are making n minus 1 passes. Hope it is clear. Right? Now, what is the complexity of this bubble sort? What is the complexity of this bubble sort? And you have to compare it based on these passes if you have got the concept. Can anyone tell me the complexity? Log n. No, it is not log n. Anyone else? How come it is log n? See, you have to make an idea. If it is log in kind of a tree, if at every step you are dividing the list, so maybe it can be log n. But here nothing is like that. You are making so many number of comparisons. Order of n, log 5 base 2, never. It can never be like this. See, let us sort it out technically. Order of n again not. N square is fine. See, actually, let us try to find it technically. Why is it so? Can anyone tell me how many number of comparisons we do over here in the first pass? How many comparisons? So more or less n minus 1. Is it so? So n minus 1 steps I can say. And in the second pass, how many comparisons? Yeah, tell me. In the second pass, how many comparisons? More or less n minus 2. And in third pass, how many comparisons? N minus 3 and so on. So if you have got n elements and in pass 1 you are using n minus 1 comparisons, n minus 2 comparisons, n minus 3 comparisons, and lastly 2 or 1 comparison. So these are actually the number of steps that we are going to take while sorting the elements using bubble sort. Right? So if we add them all, what is the total addition of this? N minus 1 plus n minus 2 plus n minus 3 plus n minus 4 up to 1. Sum of first n natural numbers. What is the total sum? What is the total sum? See, this is how do we technically calculate it. What is the total sum of this? Don't remember things as I told you in the very first start of the lecture, during the very first session. Try to figure out the things, why this, why not this. If you say log n, n square, n by 2, so this way the things won't work. Then you have to remember the things at the end of the day while you will be sitting in the exam or someone will ask you the complexity, you will at that time definitely tell the wrong one. So better is to make a concept, think of a concept and do the thing. So tell me, what is the total sum of n minus 1 plus n minus n plus n minus 2 plus n minus 3 and so on up to n? Not, I'm not saying, no, it is not 2.5. I'm just telling you the general sum. Let me clear this window, drawings. Then I will ask you like this. What is n minus 1 plus in second pass I require n minus 2 steps. And in third pass I require n minus 3 steps. Then so on up to 3 plus 3 plus 2 plus 1. What is the total sum? This equivalent to? It is sum of first n natural numbers, n minus 1 natural numbers. What is that equivalent to? Yes, it is n into n minus 1 divided by whole divided by 2, I can say. Is it so? So this is the actual complexity of this bubble sort. And it turns out to be of the order of n square. So this is why the complexity of bubble sort is order of n square. If you have any questions till now, please ask. So this is actually why the complexity of bubble sort is order of n square. Because you have got n minus 1 passes. And in each pass, in the very first pass, you require n minus 1 comparison. In second, you require n minus 2. And in third, you require n minus 3 and so on. So when you add all the comparisons, so they turned out to be of the order of n square. So that's why we are saying the complexity of bubble sort is order of n square. Is it fine? Yes or no? Just a confirmation. So you don't have to now remember why bubble sort has this now, the complexity of bubble sort. You have to know why is it so. Right? Do you have any questions? Then we'll do the program for it. And in programming, the things will become more clear. But this was important. Why complexity was like this? You don't have to now remember it. Because we are comparing the elements in passes. In each pass, you are in first pass, you are comparing n minus 1 elements with each other. In second, you are comparing n minus 2, and in third, n minus 3, and so on. So after that, when we add all these comparisons, all these stuff, they turn out to be like this. Not exactly, but like this. But it is finally of the order of n square. Yes, tell me. Any questions till now? Yes or no? If it is clear, type yes, sir. Or you can just thumbs up. Give a thumbs up if it is clear, then we'll go to the programming part of it. Okay, so we'll go to the algorithm for this programming part of this. Fine. This is the program of it. Again, let us first explain it. Then running the program is very easy. It is not a big deal. Once you have the concept, you are doing the things, then it is very easy. See here, again, it is same like the algorithm that we have. This is the program, bubble sort. We are making a class. Then we are passing an array to it. Then we are checking the length of the array, and that length we are passing to a variable n. Simple, because length is important. On that basis, we are actually calculating the complexity, and we are actually calculating to how many comparisons we will be doing. And n is important. It is, I guess, for every problem. For this outer loop, for I is equal to 0, I less than or equal to n minus 1, I plus 1. Same case. That the example that we took. If you see, what was the example? I guess 2, 3, 4, 5, 8, something like that. 3, 5, 8, 4, 2 or 3. Yeah, it was some. Let us take 3, 5, 8, 4, 2. It was like this, right? So what we'll be doing? We'll be starting with this loop for I equal to 0. We'll starting from 0 index to I equal to 0. Yes, I is less than or equal to what is n? N is simply 0, 1, 2, 3, 4. Less than or equal to 4. Yes, 0 is less than or equal to 4. For then we internally check for j equal to 0, j less than or equal to n minus 1. Yes, j is less than or equal to 0. Yes, 0, j is also 0. This is also 0. J plus plus. If now we will compare. If ARR of j is ARR of j plus 1, we'll compare these two elements. If this j is greater than j plus 1, then what we will be do? We'll swap. If not, we'll keep them as such. So here they are, this is not true, because this j plus 1 is greater than and j is not greater than, so it will remain as such. Then we'll compare these two, 5 and 8. Here again we'll check, is 8 greater than 5? Yes, it is greater than 5. Then we'll compare these two, is 8 greater than 4? Yes, it is 4, though here swapping happens. So then again 8 and 2 again swapping happens, and 8 will go to rightmost part, and this is the pass one. So with this way it will compare them, compare the all elements in n minus 1 passes. So when we run this program, let me close this, only then it will work. Clear the drawings, close. Let me share that screen. Let me write this bubble sort. I have to find it. Actually, I have created all these programs na, as per the algorithm. So it becomes easy to make you understand both algorithm and program from the same example. Otherwise, the things are like a bit difficult to synchronize. That's why I have taken this algorithm and program accordingly. Same algorithm and same program. If you check, we have discussed this algorithm itself. If you remember the example that we discussed just now. So same algorithm was there. Nothing was like here and there. So when we run this program, these elements will be sorted. Okay. Bubble sort. Yes. So these are sorted. Right? So this is the output of this program. Hope it is clear. You can pass any array, any number of elements, and they will be sorted. And we discussed its complexity and other things as well. Okay. And this bubble sort is used for whenever this I can say the data set is small and the lists are nearly so. Can anyone tell me what is the complexity of bubble sort when the list is already sorted? Yes. When the list is already sorted, what is the complexity of bubble sort? Are you order of one? No, you have not understood the concept. You are saying it is order of one, so it means you have not done it. You have not got the concept. So it gives me the perception that you are not either listening or I am not able to make things clear. Yes, what is the complexity when it is already sorted? Can anyone tell me? Yes, it is actually order of n. Because you know, there is like you don't have to perform any kind of a swap. There is only n minus 1 comparison. Yes, no swaps occur, the algorithm starts. Yes, that is the best example. Whenever you will perform the first pass, and in the first pass itself, it will check that it has not found any swaps. So it means that the list is already sorted, but still you require n minus 1 comparisons in the first pass itself. So that's why we are just saying the best case is order of n, and it is when the list is already sorted. Fine. So the best case of bubble sort is when the list is already sorted and you don't require any swaps. You require only n minus 1 comparison in the very first pass itself. Right? Clear? Is it clear? Then we'll go back to presentation. Okay, then we have got selection sort. Can anyone tell me what is selection sort? Yes. and why it is called a selection sort? Yeah. Scan all elements. It selects the smallest and place one by one at the front, because we select here the element as the smallest from the sorted and unsorted list. That is, yes, good. Anything else? Anyone wants to answer? Okay, see, it is also a simple sorting algorithm, right? If we go to this again here, but the difference between selection sort and this, I can say this, na bubble sort, that we discussed. In bubble sort, we are just comparing the elements, and then we are just bubbling up, or I can say making a bubble of the largest element, and based on that we are shifting that largest element to the right. But here what we are doing, we are actually repeatedly selecting the smallest, or I can say the largest element, depends. You can either select the smallest or the largest element from the unsorted portion of the array, then moving that to the sorted portion. So here what actually we are doing, we are just starting with the first element, then we select, not select, then we start with the first element, right? Then we try to find the smallest element in the unsorted part. For example, if you have got this array, same array I will be taking 53842, I guess it was like that. It was 53482. This was the array, right? So what we'll be doing, we'll be starting with the first element, right? So after that, what will happen? When we start with this 5, we'll try to find a minimum element in the list. Will, once I have selected this 5, right, try to find the difference in the previous one and this one. I started with this 5, right? Then I will find the minimum element in this unsorted part. The minimum element is what? It is true. Then I will swap these numbers. Swap 2 with this, the element that I have chosen as an index, right? So after that, what I will do? Then I will move the boundary of the sorted section. So in the till now only 5 was sorted. It was not sorted, but I have taken it. So when I have moved 2 over here, so I have now unsorted part as 3, 4, 8, 5. Then I will select 3, and I will check the list, smallest, right? Are you getting it or not? Again, I am repeating. Someone is asking some question. It selects one element and then the pivot is compared with. So that is in case of, I guess, this quick sort. Okay, let us discuss this one. So initially I started with 5. So I try to find the minimum in the unsorted list. Unsorted was 3482. Then if 5, there is an element that is smallest than this 5, so I will swap them. So what I will do, I will swap this. What I will do, I have now unsorted part. Let me keep unsorted part like this. It is 3, 8, 4, now 5, because I have swapped it, right? So 2 is at the initial of the list, right? Then what I will do, I will start with the 3. 3 is now minimum, not minimum, 3 is the index now, next index. Then I will try to find the element which is less than 3 in the list. If that is there, I will swap. If not, I will keep 3 to the sorted part. So there is no element within this list that is less than 3. So what I will do, I will keep it like this way. 2, comma 3. Then in the unsorted part, it is 8, comma 4, comma 5. So it is easy, right? So 2, 3 is now sorted and 8, 4, 5 is now unsorted part. Again, what I will do, I will choose 8 and try to find the minimum element in this list. Is there a minimum in the list? Yes, it is. That is 4. So what I will do, I will swap this 4 and 8. And after swapping, what I will do, I will move this 4 to the sorted part and remaining part to the unsorted part. So the remaining part would be like this. It would be 2, comma 3, comma 4, and the part that is there, it would be 8, comma 5, unsorted part. Again, I have chosen what? I have chosen 8 and I will compare it with the remaining element, that is 5. So whosoever is bigger, that will go to right, and whosoever is left, that is good, that will go to the sorted part. So here 5 is smaller, so the sorted part would be 2, 3, 4, 5, and unsorted part would be 8, and that is the only element that will remain at the end. So this way the array gets sorted. So this is how this selection sort is actually working. If you have any question, tell me. This is how this selection sort is actually working. Yes, tell me. Is it fine? Any questions? Is it clear? Yes or no? If you have any doubts, you can ask in the chat box. Then I will repeat. If not, then we'll go further to the programming part of it. Just use your chat box to let me know. Okay, shall we go further? Great. Repeat step 3. Can you repeat this sort? Okay, let me repeat again. No problem. Just ask na in the very go. Don't make me wait. This was the list, right? So what selection sort actually is doing? It is actually selecting an element, right? Means it is starting from this start. So let us do start with the element, first element. So I started with this first element. Then what I will do? I will find the smallest element. See, after selecting this first element, the array is divided into two halves, sorted and unsorted. So in sorted, I don't have anything, but in unsorted, I have the whole array, right? Like suppose 3, 4, 8, 2, right? So after doing this, now I have to compare this 5 that I have selected, the first element, with what? With the smallest in this unsorted part. So which is smallest in this unsorted part? That is 2. So once I find the smallest element in this unsorted part, I will swap that with 5. So what I will be doing? I will be swapping this 5 and 2. So 2 will go there. Then in the unsorted part, I have what? I have 3, comma 4, comma 8, comma. Instead of 2, I have now 5. Right? So I have now two arrays. One is this sorted array and another this is this unsorted array. So this is the first step. Now after that, what I will do? I will just try to do the same steps in this array. Here now I have 3. 3 is the first element in this unsorted array. Then I will try to find the smallest element in the unsorted part, means in 4, 8, and 5. If there is any, I will swap. If not, this 3 will go to the sorted part and remaining array will remain unsorted. So this way, by doing this step here, I have sorted array as 2, 3 because there is no smallest element than 3, and the unsorted array would be 4, 8, 5, right? Then again, this is sorted portion, this is unsorted, and in the unsorted portion, what I will do? I will again select this 4, this one. Then I will compare. If there is any element less than this 4, then I will swap. If not, then this 4 will go to the sorted part and unsorted will remain as such. Here it is not the case. There is no smallest element. So again, what I will be doing? I will be moving 2, 3, 4. And in unsorted part, I have 8, 5. Right? Then again, I will select 8 and I will check. If there is any element less than 8, I will swap that with 8. If not, then it will remain as such. So there is an element less than 8. So that I will swap. Means 5 will come here and 8 will go here. And this 5 will go to the sorted part and 8 will remain in the unsorted part. So in the sorted array, I have now 2, 3, 4, 5. And in the unsorted array, I have 8 only. When it is the only element, then I will merge this with the sorted part. So the sorted array would be 2, 3, 4, 5, and 8. This is how actually this selection sort is working. Right? Clear? Is it clear? Yes or no? Just give a thumbs up, yes or no. Okay, can anyone tell me now the complexity? Because we have 3, 4, 5 minutes. And why n square? That is the main question. Why n square? Like in previous case, we do so many comparisons, etc., etc. Likewise, there is some reason in selection sort. In selection sort, why it is n square? Yes. Am I getting any answers? It is order of n square. Yes. Again, good. Here also you are actually making the comparisons. If you see here now. Here also we are actually making, whenever you try to find this 5, then you are actually making these number n minus 1 comparisons. Then again in this array you are making n minus 2 comparisons. Then here also you are making n minus 3 comparisons and so on. Whatever would be then, if n number of elements would be in an array, then you are making in each step you are making n minus 1 comparison. N minus 1 in the first pass, n minus 2 in the third pass, second pass, and so on, number of comparisons. And when you add them up, they are turning out to be of the order of n square. And in best case, can anyone tell me in best case? And the best case is when the array is already sorted. See, in worst case it is n square. Even if the input is already sorted, selection sort still involves scanning all the elements unsortedly, repeat unsorted elements. Yes, this is the reason. Because whenever, no, it is not n square, it is n square, both in worst case as well as in best case. Because whenever the list is already sorted, still then you require these number of comparisons. Because at every step it has to compare. Because you are starting from the first element. If you check here also, you are starting from the first element here. So even if the list is sorted, still you have to compare 5 with, like, suppose 9, 10, 12, 13. Right? Secondly, even if 3, 4, for example, this. Yes, 3, 4, 8, it was already sorted. if it would have been here, like suppose this. If it is like 3, 4, 5, 6, 7, 8. See, even if it is sorted, still you require 3 to get compared with all 3. Then the next part, this unsorted part, again, if you are starting 4, still you have to compare it with all the elements, remaining elements. Then it gets into the sorted part. Then 5. 5 you have to compare with again with all the elements. Then it will go out of this. Then 6. 6 you have to again compare with all the elements. Only then 6 will go out. Then 7, 8 and 9 so on. So in worst case also you have to compare the elements repeatedly. That's why in worst case also it is of the order of n square. Right? Is it clear? So in both worst case as well as in best case, the complexity of selection sort is order of n square. And you know why? Because it is always searching for the minimum element while making the comparisons. Because here also we are taking n passes, n minus 1, n minus 1 plus n minus 2 and so on. When we add them up, they turn out to be n into n plus 1 divided by 2, means of the order of n square. Okay. Now there is a program for this. Let us run that program as well. It is simple. Let me share this screen. That Java compiler screen. Again, the equivalent program I have written. Yes, see selection sort over here. If we run it again, it will give you the output like this. Here, these are the elements. It is giving the sorted out. And if we explain this, if we explain it again, we are checking the length. Then we are trying to find the index. And in bubble sort, there was no concept of this selecting any element. That is why it is called as selection sort. It is selecting the element, then comparing with the remaining part of the array. And on that basis, it is moving that to the left and the remaining unsorted. Then again, it is selecting the next one, comparing that with the remaining elements. Then again, third one, comparing them with the remaining elements. Although if the array is sorted, still it is comparing with remaining of the elements. That is why in best case also, if the array is already sorted, remember it. If the array is already sorted, if array is already sorted, still it has to make comparisons, or we can say still it has to, or still it has to look for the minimum. Fine. So that is why the complexity in best case is also order of n square. Okay, hope it is clear. If you have any questions, queries, do ask me. Yes. Any questions? If it is clear, just type in the chat box, yes, sir. If the concept that we discussed, binary search, bubble sort, and selection sort. If these techniques, sorting and searching techniques are clear, give a thumbs up and type your message. Yeah. Great to see your response, and I hope it is clear. It is not only you are typing the message, and I hope you will only type it when you understood the concept. And these things are important. You know, writing a program is not difficult nowadays, but having a logic, how to build it, Why so? Why not like this? Why this? These things are important because in today's world of this chat GPT and other generative AI, you can get code anywhere. But that is not a big deal. The big deal is, although you are getting a code, you should be able to know that. You should be able to execute the steps in your mind, not on the computer. Actually, when you are a programmer, the algorithm you must execute in your mind. It should get executed line by line, kind of an interpreter that you should have in your mind. Right? So that is more important. I guess I am trying my best to make you things clear in that way. That is why I'm not more focusing on compiler like this, that way. More focus is on the algorithmic part, the logic part of the program. And why complexity I'm including every time? Because with this, if you understand how to find the complexity, that is actually the crux of the program, crux of the algorithm. Because that actually runs in the mind. When that runs in the mind, the steps are getting automatically calculated. Right? And I hope it is clear. Okay, fine. Thank you so much. Good night. Take care. Do revise the concepts. Have any doubts, do ask me. Thank you so much.
Yeah, thank you, sir. We'll wind up. We'll meet again by tomorrow at 7 p.m.
Okay, fine. Thank you so much.
Yeah, thank you. Yeah, students, I hope you all marked your attendance. As you all know, 60% of attendance is mandatory to get the certificate. So I have just shared the attendance link once again on the chat. If you missed out to mark, kindly mark your attendance. Okay, we will wind up for the day. Thank you all for joining. We'll meet again by tomorrow at 7. Thank you all.